Well, Stephen, we had a bunch of stories we actually wanted to take a closer look at because, of course, it is hot chips this week. No, we're not talking about that whole one chip challenge thing where you have to handle it with gloves, but you are probably going to want some gloves to handle the hot chips that are coming out this week. There's a lot of news. Of course, a lot of it involves AI because that is the hot topic for the chip market this year. But let's start off by talking about a company that we saw all the way back at AI Field Day 3 in May of 2022, and that's Cerebras. They are doing wafer scale computing. And during Hot Chips, they announced that they have one of the biggest wafer scale computers that you can cut out of a round silicon mold. And it completely destroyed the NVIDIA H100 GPUs thanks to a lot of high bandwidth memory.
Well, this is really kind of an interesting product. We were really blown away by Cerebras when we saw them at AI Field Day. It is very neat to see this thing in the field because, frankly, you're not used to seeing a silicon chip that's like that big. Uh, Most of the world of computing, especially high performance AI clusters, are built by basically ganging up lots and lots and lots and lots of individual units. Well, Cerebras takes that to the next level by leaving everything on the wafer. Now, you mentioned high bandwidth memory. High bandwidth memory is a specific technology that's used by the highest performance computing systems out there, including NVIDIA's GPUs, as well as Intel's best CPUs, and so on. Well, Cerebras is able to pass that by actually not using high bandwidth memory. Instead, they've got all the SRAM in the world accessible directly over this giant wafer. In other words, they're actually etching lots and lots of SRAM right there onto the same die as all of the compute accelerators, and they're able to access that with incredible bandwidth. They're able to fit actually an entire model into the SRAM on one giant wafer, and they're building this stuff out. They have deployed a few clusters of these things. We saw an early one, photos of it at least, in Santa Clara. But lately, they've built out even larger ones in Texas and Minnesota. And they're using these things historically to train models. But to me, the takeaway from Hot Chips was not training, it was inferencing. Everything is being shaken up. Now that we've basically built these massive models, billions and billions of parameters, we've got things like ChatGPT and Llama and Grok that can do just incredible stuff. Now the choice is, where do we run those models and how do we make them productive and practical? And that's what Cerebras is looking at here. They're talking about using this same chip for inferencing, which, again, I feel like, good on you. This could theoretically provide much lower latency, since the entire model could be stored right there on the wafer scale chip. And it could provide a really rapid response for consumer facing applications. For example, future smartphone digital assistants, or in enterprise where you need really high throughput of queries. In other words, I need it to be able to perform inferencing on a very small scale of time so that I can stuff tons of those things through there. That's what they ought to be able to do with their wafer scale architecture. But of course, this is just the first of a number of different announcements that we've seen at Hot Chips, all relating to how do we make AI practical.
Well, I think you're onto something there, Stephen, because Microsoft is showing off their new MAIA Accelerator for Azure. I love this thing because basically what it is a purpose built AI accelerator for open AI workloads in Azure. Like, you can't get any more specific than that. It is their first generation custom AI accelerator. And like I said, it is dedicated to running OpenAI workloads, which we know that Microsoft has really invested in OpenAI recently. So, will companies want to pick this up, or are there going to be some concerns about Azure basically saying, hey, we would love it if you'd run OpenAI on our hardware and maybe reduce your cost not running NVIDIA? Do you think the NVIDIA folks will be happy with that?
Well, I definitely think NVIDIA will feel the heat from what Microsoft is doing. As we've talked about in the past, OpenAI runs things like ChatGPT in Azure themselves. And so when you're using ChatGPT 4, it's probably running in the Azure data center. It had previously been running on a variety of different hardware, but this MAIA Accelerator is very, very interesting because essentially, as you said, Microsoft has developed their own ASIC specifically designed to run OpenAI models efficiently in Azure. This is not a product. This is not something that they're going to be selling to third parties. Frankly, I don't even know if they're going to allow customers to use it. Maybe they will, maybe they won't. But the bottom line here is that Microsoft is really focused on making sure that they can run OpenAI's models efficiently and thus, I assume, profitably by using their own hardware. Now, another reason to develop their own hardware, of course, is because they are going to be reducing their requirements on NVIDIA hardware. That's been a challenge sometimes because it's difficult to compete with all the other buyers of NVIDIA hardware in order to be able to spec and build out data centers to run these models when everybody else wants that too. And another really interesting thing, as my friend Patrick Kennedy points out in the Serve the Home article that we'll link to, is that MAIA is not using the most advanced high bandwidth memory. They're actually using a previous generation of HBM, meaning that they're not actually trying to compete with NVIDIA and AMD in terms of procuring the most advanced memory chips, which again says to me that this is a lot about supply chain. This is a lot about making sure that they can provision enough chips and build out enough chips to meet customer demand from OpenAI rather than trying to build something that's another generation forward in terms of performance. Another thing that's interesting here, of course, is that Microsoft is not really talking about comparisons on a per watt or per dollar basis because this is all in house stuff. Why would they talk about that? What they're interested in here is their own internal efficiency. And the fact that Microsoft put all this time and effort and energy and built out this very, very cool product for their own use suggests to me that this is really going to have more to do with Microsoft's profitability and share price than anything else. So it is a very, very cool product going forward. And others are getting interested in developing their own AI ASICs as well.
You're absolutely right, Stephen. And one of the companies that goes out and makes a ton of ASICs is our friends over at Broadcom. And during Hot Chips, they showed off some of their new ASICs with optical attached devices. Now, for those of you who may not be 100% familiar with this, this is the culmination of a concept known as silicon photonics. One of the things that we've seen over the last few years is that as we start putting more and more devices on the boards of these servers, on these switches, on everything, is that we need to pass data back and forth, right? That's what those little copper traces are on all the silicon boards. Well, the problem is that it takes more and more power to run those things. And little physics lessons for you folks. When you add more power to the system, that energy that's created has to be bled off somehow. And that's how you get heat. And all the way back years ago at one of our networking field day events, Andy Bechtelsheim of Arista said that we are going to quickly hit a point where it's not the ability for us to send power to a unit that's going to be basically an event horizon. It's the heat that's generated from that unit. And we're already starting to see that. And what Broadcom is doing is kind of interesting. They're not just doing silicon photonics for the interconnects for the networking gear. They're actually using silicon photonics for chips, like the CPUs on the system. So imagine a co-packaged optics CPU that is using light pulses to trade data back and forth instead of using traditional copper. That to me is big because you've got to turn that corner. This is not a research project anymore. This is something that they are genuinely looking at doing. And they have a massive amount of data that shows just how important this is. Looking at the story that we're going to link, of course, from Serve the Home, one of the things that they talked about was the fact that the power consumption for a 200 gigabit module was about 13 to 15 watts. When they used co-packaged optics, they brought that down to 5 watts. So think about that. They reduced it to a third of its power consumption. And you're probably sitting there thinking to yourself, wow, 15 watts to 5 watts, that's not a whole lot. I mean, my iPhone charges at 15 watts. Yeah, now imagine 128 iPhones all charging in a space the size of a shoebox. Imagine how hot that's going to get. Now, imagine if it was a whole lot less heat intensive. That's what they're trying to do. It also reduces the power consumption overall in the switch, which means we don't have to have these dedicated nuclear reactors and water cooling. I mean, we kind of hinted at that with some of the other things. Even the Microsoft MAIA chip has a water cooling option, because what we're finding is that AI workloads are seriously driving the performance of these units. And one of the other cool things that I think Broadcom has kind of gotten onto their heads is they have a pluggable laser that goes into these co-packaged optics. So the laser can be replaced when it dies. Lasers are consumable parts, just like car tires and brakes and everything else. They're going to die. And some of the first generation of Intel's silicon photonics systems did not have replaceable lasers, which meant when the switch died, because the laser died, you had to toss the whole thing. You couldn't just go in and pull it and replace it. So I think Broadcom has an eye to upgradability, extensibility, repairability for these systems. And I think it's going to really drive the market forward. And I would not be shocked within the next 5 to 7 years that we see a lot of these high performance, hyperscale workloads going with co-packaged optics and even co-packaged CPUs using silicon photonics to drive performance to unparalleled heights. I mean, we're talking 10x performance increases that are projected over already wild performance specs, simply because we're trading out using electrical signals through copper for light pulses through optics. All right, another big story that we saw was from our friends over at IBM, because they are talking about using an on-chip DPU for big iron. And one of the things that we kind of heard maybe a little bit about when you were out at the Share conference earlier this month was about Telum 2 and Z17. And of course, our friend Stephen Dickens was able to talk to some IBM engineers about that in the Infrastructure Matters webcast. But Stephen, since you were there and you kind of heard what was going on, why is having an on-chip DPU so big and so important?
Well, the interesting thing about mainframe, first off, as we saw at Share, is that mainframe definitely is not dead. It is modernizing, it is embracing DevOps mentality, and it's embracing AI. Now, as you mentioned, there was a lot of buzz at Share about what IBM might do next. In fact, I kind of wish Share had been a month later so that we could have seen from or heard directly from IBM about the Z17 and where they're going next. Theoretically, that's what IBM is going to do with the processor that they showed at Hot Chips, because essentially that's what they did with the last one processor at Hot Chips 2021, which became the Z16, which is the current state of the art in mainframes. Now, the thing about mainframes, the thing to know about mainframes is that it's all about integration of diverse components and offload of workflows to different components within the system. The brilliance of mainframe is that it is all about this sort of offload aspect, and that's something that of course we're embracing in the non-mainframe world as well. But IBM has been doing this, well, I don't want to sound like a broken record, but IBM has been doing this for a long time, and that's what makes their system special. So yeah, what we heard about from IBM at Hot Chips, and what our friend Stephen Dickens talked to Chris Berry and Susan Eichhoff about on Infrastructure Matters, is basically the next direction for IBM. And no surprise, they are embracing this whole idea of an XPU or DPU. They're embracing the idea of doing AI acceleration. IBM has been working in this field for a long time. They have a lot of credibility and clout in the AI world. And that's exactly what we're going to see in the next mainframe, I'm sure. Essentially, they're going to be doing the same thing that Amazon or Google or any of these other companies is doing by adding coprocessors in there to handle AI acceleration. That's pretty cool, because when it comes to enterprise workloads, or even, I guess, world class workloads, you could call them, the mainframe is still where it's at. So if you want to do inferencing against banking and financial data, or airline travel data or things like that. Well, it's all going to be happening on the mainframe. And instead of shipping that data off of there onto some other GPU cluster or something, you can actually do all that processing right there within the mainframe. And again, mainframes are focused on throughput and latency, essentially pull data through, process it quickly, and get it out the other side. And that's how literally the entire world's financial system works. And by adding a bit of AI acceleration to that, I think that we're going to get some really nice next generation products here built around mainframes. So it is interesting to be talking about mainframe in 2024, but boy, IBM's doing some really cool stuff here.
Speaking of traditional tech companies who are betting big on new technology, we're seeing some more details around Intel's Gaudi 3. Now, of course, we're all waiting for Falcon Shores because that's the big AI chip, right? But we can't just pin our hopes on promises of what's going to be, because as we know, the beleaguered chip giant has been facing some headwinds. And as our own Daniel Newman said, they've got to land Gaudi. This has to happen. Otherwise, they really don't have a future in AI. But they started showing off some of the cool things that were in Gaudi for real at Hot Chips. But they have discussed Gaudi before at AI Field Day 3 back in May of 2022, and then also at AI Field Day back in February. So I'm kind of curious, Stephen, what is it about Gaudi that thinks that Intel has a good place here in the market, or are they just kind of treading water until Falcon Shores can come out?
Well, it's interesting. I think that Intel has no choice but to tread water because, of course, they don't want to drown. And of course, most of the focus has been on NVIDIA processors for AI processing. The same is true, honestly, for companies like AMD, Marvell, Qualcomm, Broadcom, and yeah, smaller AI startups like, we talked about Cerebras and Grok. All of these products are actually really good products. And Intel with Gaudi 3 actually has a really solid inferencing platform here. Essentially, they've got a chip that works well. It's lower powered, it's lower cost, it's definitely competitive, it's available. The fact that this hasn't seen more uptake just shows the power of NVIDIA in this market. Essentially, NVIDIA dominates the AI space with their GPUs and associated chips, and everybody else is fighting over the scraps, including Big Daddy Intel. Now, Gaudi 3, Intel is doing the right thing here. They're basically going to hot chips and they're showing the promise of their platform. And it is extremely promising. They have a very, very solid product here. The problem is that customers just aren't buying as much of it as they, well, might, because frankly, everybody's so focused on the NVIDIA stack. So Intel has been investing in alternative software approaches and APIs to open the door to make it easier for people to run things on Gaudi. They're showing all of the cool capabilities they've got in here. I mean, Gaudi has some really neat things like video processing codecs, so they can process video and photo data much faster. It's got Ethernet connections, all sorts of capabilities that you might think would make Gaudi attractive to end customers. But the market has been, I think, a little slower to develop than many would have thought, including myself, in terms of turning that corner from training to inferencing. And frankly, when it comes to inferencing, a lot of folks are basically using whatever happens to be available in the cloud without really worrying about who's making the processor. So that has benefited companies like Microsoft and AWS and Google, but it hasn't really benefited companies like Intel as much as it could have. And most people aren't yet going out there and building their own inferencing clusters and so on. So I could see this as a very, very promising product. I could also see it as treading water. We'll see what happens with it. I think that if you are out there looking for an alternative for running production AI workloads, Gaudi's an interesting hardware product, as well as some of the other competitors in this space, including Grok. But at the same time, it doesn't look like there's much of a market for that up till this point. I do expect that market to be developing. And for me, that's the big takeaway from Hot Chips, is that we are turning the corner and this market is developing. And I think that that is actually promising for companies like Intel and AMD and Grok and all the rest, as there potentially will be a new market for their products.